the changes goes. And then I want you to write a small handoff document that says which version rasterizer are we currently using, and tell Codex to fork that, and then tell it that we want it to support arbitrary feature splatting so we can configure the size of the feature channel. All right, I'm gonna dump it off. And so I gave a bunch of stuff there, kind of outlined the problem, but I outlined a bit the approach I want as well, because Claude still kind of struggles at writing GPU code. It's okay, it's not terrible at it, but Codex is just awesome at this. And so I'm gonna, first I want to take that command too before I forget. So let's see. Here we go. Here's the command I was looking for. So I just want to show you guys what I mean when I say Claude runs training, and it just means it runs this command. And so it does UV run, which handles our dependencies. It sets a Python path for it. And then it trains this video token implicit. And so that's that same code I was showing you here. Token implicit, this is how the model works, where it predicts a camera, predicts a render from a camera. And we could even look at that train script while we're kicking it off. And so you can see it goes here, and the loss starts high and just slowly goes down. Looks like it takes about a minute or so to run, nothing crazy. And let's see if we can find, so the name of that script was, let's see, right here, train video token implicit dynamic. So we have a couple trainers here that just do different things. One trains implicit, one trains not implicit. Looks like, of course, there is two of those with very similar names, because vibe coding sure is not perfect yet, huh? So they just spelled implicit wrong in one of these, but that's okay. We'll go to this one. And so we can take a look at how the training loop looks. And so a lot of this at the top, this is just configurations. It's kind of messy and not that important. Just kind of load this stuff, pass around parameters, things like this. And then this is evaluate metrics. So it basically renders 2 frames, runs loss, MSE, SSIM, set structure of similarity, all these things. This is render full sequence. So it goes through each frame, takes the frame, renders it. So it's going to say calls our model. So this is kind of the core of the train loop right here. If we look, and it's take our batch of frames. So we pull a frame from our video, pass that into the model. The model then gives us the decoded state. Take our camera states, append these, and then we're going to go through this, and we're going to say render frame. So it takes the frame, gets the result for every frame, and then renders the implicit frame for each one. And then we're going to build up our camera state, and then we will run training. And so this is the just bigger loader that handles like get our data loader, get it over. Here's go every step. And so it's for each step in P bar. P bar is what gives us this nice progress bar here. Let's just take each batch, run it through the model, decode it, render the frame, stack them all up, get your loss. And then here's all our losses added together. We have a few different ones. Backward step, optimizer step, boom. And then this is all logging below. So this is a bunch of logging this is how we understand what's going on, if our certain metrics are unhealthy or not, but for now it doesn't matter. So I logged a lot of these in the past to help me debug stuff, but this is the core kind of training loop here if we look from optimizer step to this one. So dense little bit of code here that does the main magic. And it's grab some frames, use the model to predict them, render them, check, is it equal to